Hi, we're the LLM Evaluator team, Team 9 from Washington State University. This is our team. It's Elliot, Ryder, Nihal, and Harry. We're all programmers, senior year computer science majors with other minors and studies amongst us. Our objectives for this project were to develop repeatable testing frameworks for LLMs because it seems like every day new AI is coming out. I mean, as you can see here, DeepSeek, Grok, Cloud, OpenAI, Gemini, these all came out in the last couple of years, and they all perform differently along these different benchmarks. And so it's really hard to say, hey, how well are these different LLMs performing against each other? This is our problem statement. And so we're building evaluators to determine the current model, how they stand against each other. And this is the architecture that we have designed. So first, we have the LLM evaluation UI. This is either a Python environment that you can just call, or you can call it through command line like PowerShell or whatever. And so you have the input parser, which takes your API key, calls the API, returns several prompts. We have a system built where you can build as many prompts as you want, or you can use the pre-built prompts. There are a couple different types like creativity, factual correctness, perplexity, and social, like how well it impacts society for its response. And then we evaluate all of those. That's our evaluator handler right here. Um, and then we multi-process and can aggregate all of these pieces of data into a CSV file, stamp the current model name and the date, which is then saved to a CSV, which you can see here. This is example data that can be stored in a database or a locally. As you can see here, here's the model name, here's the date that this CSV file was made and tested during, and then here are many evaluation metrics like blue, rouge, meteor, depth, standard deviation, all of these different things for how varied the LLM's response is. And then, so the technology we use to build these aggregators and all these evaluators are we use GPUs for things like BART and other LLMs that we use to evaluate the response text, the APIs for the LLMs, and then we use Blue, Rouge, Perplexity, BART, all, or not BERT, BERT, not BART, and then Python is our general framework that everything is built in. The impact and benefits that this will have on the greater computer science world is that you can see how the current model may stack up. You might see that, for example, ChatGPT 3.5 a couple of weeks ago said that Raspberry had two R's. Raspberry actually has three R's, which says that it may be the same model, but it's now performing differently than it used to. And so this can help show how these models, even under the same name and supposed model type, are changing over time, so you can see how they currently stand against each other. What can still be done is this can be uploaded to a software bank like Shiny or something where it's hosted online so anyone can see and enter their API key only to have it scrubbed and then ran to then see how LLMs are currently being held against each other. And then it can also be all of this data can be stored in a database by the company, Hacker Earth. Thank you for this amazing opportunity to work on a real world issue with an amazing client.